eclipses, but just as I look again, I mean, it's incredible how the moon and the sun are able to line up like this.
And again, I mean, the moon is way smaller than the sun, but right now it's really giving it a run for its money.
It is. Yeah.
Why is that?
Well, so a little fun fact about our moon, it's pretty incredible. It's 400 times smaller than the sun, but it's also 400 times closer to the Earth.
No way, 400
is the magic number here, yeah. The fact that 400 and 400, that means in the sky, the moon and the sun appear to be the same size. And that is unique to us on Earth. No other planet in our solar system has that ratio that makes it so special.
So you're saying that if we viewed an eclipse on another planet, it wouldn't look like this?
It wouldn't. I mean, I'm sure it would be great to see, but it would not look as spectacular as this.
Wow, okay, I'm gonna turn behind me really fast.
Yeah, looking around. And you can just see everything. The shadows are a little bit different. It's dim. You get this hazy feeling, but the sky is so blue. That's what's strange about it.
Oh, it's so sweet. We've got parents like holding little eclipse glasses on their kids to look up. This is just, it's really amazing how just like, I don't know, a natural phenomenon can really make the world pause for a second.
Right.
Wow.
You heard the cheering, and now it's quiet again as people are just looking.
And so, for us, this is going to last about 4 minutes until it crosses, right?
That's right.
And why is that? Is that the same in every city, or?
Yeah, so there's actually, the length of the maximum eclipse can change based on several factors. I mean, each eclipse is unique, and so one thing has to do with where in the moon's orbit the moon is, because the moon's orbit isn't circular, so it will go faster and slower at different parts, and that will make the shadow travel at different speeds. Also, where the shadow is landing on Earth will have an impact, because if you're at the equator, you're going to be rotating much faster than if you were at the poles, and so for that fact, it changes the length of that maximum eclipse too. And that's true not just for annular eclipses, but for the partial eclipses, for the totality, for total solar eclipses as well. And I imagine, our folks at home getting some of those partial eclipses are also having a great experience too.
I don't know what I expected, but it wasn't this. Like, this is incredible. And so, Gina, I'm sure, I mean, you're in heliophysics, sun science. I'm sure some of your teams are studying today's eclipse. Like,
oh yeah,
what?
Absolutely.
So, what kind of science can only happen right now,
Right, we've heard about the sounding rockets that are experimenting.
That's right,
today,
we saw one, yeah.
Studying the upper atmosphere, and so we're really interested in knowing, like right now, in our location, as that radiation from the sun's being blocked, how does the upper atmosphere change? And so, in addition to that, I mean, we really want to understand how those sunspots, what's going on when they're covered versus when they are not covered. We can tell the difference in that radiation that's coming from the sun. And so there's so much science that we can do.
And this is just, folks, this is